Okay, so today we're talking about the distance formula. So what I've got drawn up here is like a little tiny coordinate plane, and what I've got are two little points on that plane, and I've just given them a general notation of x1, y1. That just represents a number. So let's say this point was 1, 1, x1 would be 1, y1 would be 1. All right, so these are just general notation. If this is point x1, y1, and then this is point x2, y2, then we want to find the distance between those points. Somebody has worked out that there is a formula that we can use to find that distance. Okay, and that's over here on the right. We're going to say d. D here is going to represent the distance between two coordinate points on the plane. Okay, so d is going to be equal to the square root of the one x coordinate minus the other x coordinate squared. Doesn't matter which order that you do it in, which we'll see in a minute, plus one of the y coordinates minus the other y coordinate squared. Okay? So that's the formula. It makes more sense, I think, if we do some examples, which I have down here. So down here I've got two coordinate points. I want to find the distance between them on the coordinate plane. So first thing you have to do is figure out what x1 and y1 and x2 and y2 are. And the answer to that question is it's whichever one you want to make it. So in this case, if I want to say that this is x1, y1, and then this would be x2, y2. Notice you don't have to label it that way. You could have called this x2, y2, and this x1, y1, and you're perfectly fine as long as you follow the formula. All right? So now the distance formula, which we have above, says that d is equal to the square root. So we're going to take x2 minus x1 squared. So x2 we're saying here is negative 4 minus x1, which in this case is 5 squared, plus y2 is negative 1 minus y1 here is 2 squared. And that's all there is to it. You're just taking coordinates and plugging them in. Notice since this was x1, y1, we put it in that order and make sure that whenever we're going to y and y1 and y2, we want to do it in the same order that we did x1 and x2. And now it just becomes a game of crunching out what's underneath of this square root sign. So d is equal to the square root. All right, so negative 4 minus 5 is negative 9. Negative 9 squared is 81. So we'll put 81 plus negative 1 minus 2 is negative 3. Negative 3 squared is 9. All right. So then d is just going to be the square root of 90. And in terms of geometry, if you want to leave it like that, you're fine. In order to get the square root of 90, you'd have to use a calculator, which I don't have right now. But basically, you'd plug it in, second X2 button on the TI-83, and then type in 90 and hit enter. And it would give you something like, 9 point something. All right. So D is the square root of 90, which is perfectly legit to leave it that way. All right. Take a second and try this second example and see what you come up with. And I'll pause the video and I'll be back in just a second. Okay, so here we are. Just to show you that it doesn't matter which order you pick these things. Over here I said the first coordinate was the 1s. Here I'll make this x2, y2, and this can be x1, y1. All right, we'll plug it into the formula. So d is equal to the square root of x2 we're saying here is 2. 2 minus x1 is 2 squared plus y2, which is negative 1, minus y1, which is 5 squared. So d is going to be the square root of 2 minus 2 is 0. 0 squared is 0, which you don't necessarily have to write. Negative 1 minus 5 is negative 6. Negative 6 squared is a positive 36. So d is going to be the square root of 36, which in this case is a perfect square and gives us 6. Okay? If you have any questions, bring them to class.